Hey all, this is the last video for the year. It's the last review video. We're going to talk about some of the basic things we talked about at the beginning of the year. So the first one was when we find distance or length in the coordinate plane. We have 2 points. We want to find how far apart they are. So I'm using E and F here. And there's the coordinates. Remember that we use the Pythagorean theorem. So for A, I just subtract the two x's. So I can do 4 minus 1. For B, I subtract the two y's, so negative 5 minus negative 1. And then I continue to solve to get C. So you should try that on your own. You should get that C is 5. This guy is 5 units long. So anytime you see the distance between 2 points, they give you coordinates, or if they want to know the length of a line segment in the coordinate plane, we're using the Pythagorean theorem. Remember, guys, that is on the formula sheet. We had two formulas when we were talking about midpoints. The midpoint is right in the very middle of a segment. So in the coordinate plane, we'll use the midpoint formula. To find the midpoint of segment AB, all we need to do is add the two x values together and divide by 2. So 2 plus negative 3 is negative 1. So the x value is negative 1/2. Add the y values and divide by 2. So 5 over 2, that gives you 2.5. So my midpoint here is negative 1/2 positive 2.5, which is right there. Let's suppose that A is one endpoint and B is the midpoint, and we want to find C somewhere over here. That's the other endpoint, somewhere over here. We can use this formula. Remember, I'm going to look for coordinates, so that's why I have parentheses. I double the x value of the midpoint and I subtract the x value of the endpoint. So the x value of the midpoint, if B is the midpoint now, we multiply it by 2, that's 4, and subtract the x value of A. So 4 minus negative 3 gives us 7. So the x value is 7. So we're somewhere over here. I was pretty close. 7. For the y part, we double the y value of the midpoint, so double the y value of B, since B is the midpoint in this example. So 2 times 1 is 2, and then subtract the endpoint. 2 minus 4 is negative 2. I know that's kind of big. So we are at 7, negative 2. I was close. It's probably more like right there. That would be the other endpoint if B was the midpoint of my segment. A couple of types of angles to remember. Vertical angles, anywhere we see two lines crossing, these angles that are kind of opposite each other are vertical angles. 7 and 8, 4 and 3, 1 and 2, 6 and 5. And it's important to know that vertical angles are equal in measure. They're congruent. We didn't really use this word adjacent, but two angles that make a straight line we call a linear pair. So 1 and 2, 6 and 5, and we know that those pairs of angles are supplementary, meaning they add to 180. We talked about parallel lines and perpendicular lines and how their slopes are related. So in the coordinate plane, if I have two lines that are parallel, their slopes are going to be equal. They're the same value. If the lines are perpendicular, meaning they intersect and form 90-degree angles, they're going to have slopes that are negative reciprocals. So that means if I start with a slope of 2, which is the same as 2 over 1, I want to make sure I write that. 2 is the same as 2 over 1. I can just flip this fraction and get 1/2 and change its sign and make it negative, and that's the slope of a line perpendicular. So the slope of a line perpendicular to a line that has slope 2 is negative 1/2. Last but not least, whenever we had parallel lines, remember these arrows on these lines mean they're parallel. We had 4 different types of angles we talked about. We had corresponding. You can see the different colors match up. Corresponding angles. I have 4 angles here, 4 here. Corresponding are the ones that are in the same location. So 3 and 4, 7 and 8, 1 and 2, 5 and 6. And those are equal in measure. They're congruent. Alternate interior angles are on the opposite side of the transversal between the 2 parallel lines, and they are also congruent. So 3 and 4, 1 and 2. Alternate exterior angles are equal in measure, and they are outside of the 2 lines and on opposite sides. So 3 and 4, 1 and 2. Last but not least, same side interior angles or consecutive angles are supplementary. They look like they're 2 angles of maybe a parallelogram inside there. So 3 and 4 add up to 180. 1 and 2 add up to 180.